Okay, here's our block that we did the other day. I'm going to pick this thing up here and show you what we've got. We've got the threaded hole here. The screw goes in and out of there. Here's the countersunk hole for a flathead screw, and you can see the angle on the head of that screw. It drops right in there. Here's the socket head cap screw that goes in the other hole right here. It's counterbored. So if you get all those lined up there, all those heads of those screws are below the surface of the block there. Here is a real big countersink for countersinking those holes for the flathead screw. And I mentioned some time ago that the countersinks are chatterless, so somebody had a good idea to make here's two flutes on this countersink and two here, but the gap between these two is different, so there's no vibration set up because all the cutting flutes are equal, so they staggered the cutting edges. But that's a big countersink. That's a 2-inch diameter one. I think the one that we use for our block here could have been a 3/4 one, but I wanted to make it something you could see to show what the countersink actually looks like. Here's a reamer. We talked about reaming holes out. It's got many flutes compared to a drill. This is a little bit bigger than the one that we used, but I just wanted to show you the flutes that are on there. And this thing turns a lot slower than a drill bit because it's got more flutes, and this is something you're going to want to make a cut to give you a dead straight, round, true sized hole. A drill can drill a little bit oversized depending on how well it's sharpened. Here's a tap. This is kind of a long extended one. I did that so you can kind of see what that looks like, but you can see the teeth on the tap. When you drill the hole 27/64 and then you go into the 1/2-inch diameter tap, the teeth are going to cut the threads in the hole. That way you can get your screw in there and get a good pull on the screw. This is a dowel pin here. It's not the one that fits in this size here. We made a 5/16 dowel pin hole, and that's 0.3125. If you measure a dowel pin, it's about 2/10 of a thousandth bigger than what the reamed hole is. So if the reamed hole is 0.3125, the dowel pin is going to measure 0.3127. That way you got to tap it in with a hammer. It'll just go in, and when you are a dowel pin is used to help locate one block on another by using reamed holes. The pins get pushed in there. They're tight as all get out, and you need 2 dowel pins for each 2 pieces that you're holding together, so you can get the good location so it stays where it's supposed to be. But anyhow, you see on my desk here, I've got the decimal equivalent chart here, and there's a machinery's handbook, which has got a wealth of information in it. My calculator, because I can't always figure out some of these dimensions real easy, know them off the top of my head. Especially if you get a metric drawing sometime, you might get something that says 12 millimeters, and you're going to say, wow, what's that? Well, then you figure out what 12 millimeters, you divide that by 25.4, and it'll give you your dimension, which is, let's just do it real quick here. It's about 468 or something like that. 12 divided by 25.4 is, yep, 472, I said. I don't know if I said that or not, but that's what it is. Anyhow, these are some of the typical tools that you'll use in the holes that you put in. So we talk a little bit about the holes. There's our block that we made. You see all the different holes. That's the one we drilled in an earlier video. You've seen the CAD drawing here now of what our parts look like and what we have to portray on the image of the drawing to anybody that's going to be making this part. So sketches are okay. You can sketch it out on a piece of graph paper. Usually they're 1/4-inch squares, and you can draw the item out, get all your information on there, and then you've got a record of what your part is and a history of what you have to do if you need to make another one. So anyhow, we'll get back to the topics here as we go. Thanks for listening today. I'm gonna get the next one going here in the next few days probably, so keep tuned. Be sure to share and subscribe and like the channel here. I want to try to get this out to as many people as possible. I'm sorry I didn't get this drawing in a format that you could read, but if you're looking at it and you can do a pause and do a print screen, hopefully you can see some of the details on it. If not, I'm working on figuring that out yet. I'm not a tech savvy guy for doing all this electronic stuff here, so you gotta bear with me, but I'll teach you plenty about machining. Anyhow, thanks again, and we'll talk to you soon.